reorder level is the same as reorder point. Is the same as reorder point, and normally it reflects the consumption. It reflects the consumption during lead time. Consumption during lead time. How many units shall we consume over the lead time period? Ladies and gentlemen, here they have given us the consumption per day. They have given us in this question, if you go to the question, you will see they have given us the demand per day is 130 times the lead time. The lead time has been given there as 5 days. So 130 times 5 days, 130 times 5 days, what figure will we get here? 130 times 5 days. This gives us 600 what here? 50 units. 650 units. So anytime you hear this examiner asking you about the ROP, the reorder point, always remember the concept of reorder point or reorder level being the aspect of the total units here that will be consumed over the lead time. Here we are consuming every day 130, and since our lead time is 5 days, so 130 times 5 will give us 600 what here? 650, ladies and gentlemen. I hope that is clear. And then I would want us to go to number 2. Number 2, they want us to give them the safety stock level. The safety stock level. Ladies and gentlemen, this question is quite different from the one that we were doing in our last class. And really, what is the difference? Here, they have not given us the stock out cost per unit. The stock out cost per unit has not been given. So please write there that the stock out cost per unit has not been given. The stock out cost per unit has not been given. After full stop, you tell us there that the examiner has provided the service level. The examiner has provided the service level into brackets, which is 85%. Into brackets, 85%. You'll be able to see in that question before the requirement, they are telling us that the company targets an 85% service level during what year? Lead time. 85% service level during lead time. So if the examiner gives us service level, then we need to understand, first of all, what this service level means. We need to understand what the service level means. Ladies and gentlemen, our service level will look like this. Service level. Service level. Tell us, ladies and gentlemen, that service level reflects, basically this reflects what? It reflects the maximum. It reflects the maximum number of customers. Number of customers that a firm, is willing, to serve. That a firm is willing to serve, or basically to attend to the maximum number of customers that a firm is willing to serve. Now, ladies and gentlemen, as much as really would want to serve everyone who comes to our organization, it may not be practicable. It may not be practical. The investment is going to be so huge. So in this case here, at times, we are required here to take some risks. Say that, like in this particular case, we would want to serve only 85% of the customers we get. If you're stretched, if you're so much stretched, if we get, in this case here, so many people coming, for example, to this particular online platform, like through Zoom, our service level is 100 students. We can only serve 100. We can't go beyond what here, 100, not unless we pay more money to Zoom. More money to Zoom. So if you pay more money to Zoom, the next category will be 300 students, which is going to be costly, and maybe as a school will not be able to get 300 students. So at times we are required to take that risk and define the maximum number of customers we may want to serve at any given time. And as such, we put down what we call service level. Anytime they give me service level, ladies and gentlemen, then that is an examiner who wants me to survive and pass this very well. Once they give me a service level, for me to be able to answer them, what I need is what we call the demand. The demand. So in this case here mentioned there, the demand. You can see our demand like the first one. We have actual demand during lead time, You can see the first one is 300 to 399. 300 to 399. We don't prefer doing analysis whenever we are given demand in form of a range. So if you're given demand in the form of a range, simply give us the midpoint. So who can give us the midpoint of this? So we want the midpoint. We want the midpoint. DD stands for demand. We want the midpoint. So the midpoint, you take 300 plus 399. 300 plus 399, whatever we get, we divide by 2. We divide by 2. Who is able to give us an answer there very fast? Who is able to give us an answer there very first? 349.5. Allow us to work with the whole numbers because these are consumers, consumers. So please allow us to work with 300 and what here? 50. 350. So could you kindly go to the next class? The next class I can see there 400 to 499. So then what is the middle value? What is the midpoint? You take 400 plus 499 equals, you divide by 2 and then you give us a whole number. Give us a whole number. Even if you are to work with decimal, still no problem. But here for demand, really consumers, we expect whole numbers. Is there some student who is able to give me answers here very fast? The second one is supposed to be? The second one is 450. 450. The third one? The third one, they haven't given us any figure. They will give us. Because the third one, we are supposed to take, ladies and gentlemen, the third one, we are supposed to take 500 plus 599 divided by 2. Plus 599 divided by 2. 550? 560 or 550? 550, several of them. So after that, ladies and gentlemen, you'll be able to see 650. And then we have 750, 750, 850, 850. And then lastly, we have 900 what here? 950 like that. 950 like that. Now, ladies and gentlemen, from there I can see they have given me frequency. In management accounting, just like in financial management, whenever you are given frequencies, the examiner is giving you a free mark. A free mark. In which way? So you can see 0, 16, 0, 16. The next one is 20, 25, 20, 25. We have 14, 8, and 3. Whenever I'm given frequencies, ladies and gentlemen, I have to use these frequencies here to develop probabilities. And how do I get probabilities out of frequencies? First of all, you give us the total frequency. Give us the total frequency. So who is able to add this for us? The first thing that you have to do for you to be able to get probabilities out of frequencies, first of all, give us the total frequency. Look at my comment there. My comment there. Is there somebody who has been able to give us the total frequency? 86, eh? Mary Murioki is saying we have 86 here. Thank you very much. Now from there, to convert these frequencies to probabilities, what we shall do is to call these relative frequency. Relative frequency, where we relate these individual frequencies here to the total. So then these will be 0 divided by 86, 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 divided by 86. The moment you do that, then you will have stretched in getting what we call probabilities. Probabilities. I want this to be your game. I want this to be your game. And for it to be your game, you must give us figures. Of course, I have a calculator here with me. But you see, this is not my ball. This is your game. So like the first probability, I can see it is what here, somebody? 0. The first probability there is 0. Go to the second one, which will be 16 divided by 86, which gives us 0. Aha. You have to change that. Sorry for that. So let's proceed. Yeah, let's proceed. Sorry for that. So we have here, ladies and gentlemen, if you're able to hear me, please give me this second probability. This second probability, what do we have there? 2 decimal places. 0.19, thank you very much. So 0.19, from there we have the third one. The third one will be 20 divided by 86. 20 divided by 86 gives us 0.23. Oh, they already have the figures. 29. The next one is 0.29. Thank you very much. The last, second, third last. 0.16. Thank you very much. And then 0.09. 0.09. Lastly, what do we have here? Somebody? 0.03. 0.0. So 3 divided by 86. 3 divided by 86 is supposed to be 0.03. 0.03. Thank you very much. Thank you very much. Thank you very much. Of course, because of rounding off errors, you may not get the total being what here. You know, this total is supposed to be exactly what? The total is supposed to be exactly 1. The total is supposed to be exactly 1. So could you kindly try to see whether the total is exactly 1? Try to see whether the total is exactly 1. So what do we have here? 0.19 plus 0.23 plus 0.29 plus 0.16 plus 0.09 plus 0.03, which is giving me 0.99. 0.99. Meaning that if I do this, it will not be right. We need to come and make an adjustment on the last figure. So the question is, I can see there is a difference of 0.01. So we make an adjustment to the last figure. So the last figure ought to be 0.0 what here? 0.04. Normally the adjustment is done on the last figure. So to get the last figure, the balancing figure, you need to take 1, you subtract all the others. You take 1, you subtract, what are we saying? You take 1 minus open brackets, all the others. So we have 0.09 plus 0.16 plus 0.29 plus 0.23 plus 0.19 plus 0. If you do that, you'll be able to get the last one is 0.04. This is what we call mutual exclusivity. That we expect the total probability to be exactly what? To be exactly 1. To be exactly 1. Now, ladies and gentlemen, after that, I will come and create the last column called the service level. Service level. Service level. Service level. Service level basically captures what we call the cumulative probabilities. It captures what we call the cumulative what here? Probabilities. Cumulative probabilities. So you simply accumulate these probabilities down. You accumulate these probabilities down. So what do we have, ladies and gentlemen? While accumulating this becomes 0. 0.19 plus 0, that gives us 0.19. And then you come and lump this figure, you keep on accumulating. So with your calculator, I have here 0.19, what I've gotten there, plus 0.23, which will give me 0.42, plus 0.29, which will give me 0.71, plus 0.16, which will end up giving us 0.87, plus 0.09, which will end up giving us 0.96, and then of course plus 0.04. Now we should be able to get exactly 1, like that. We should be able to get exactly 1. Service level, service level. What does this service level mean? If you've done this in your normal class, you know that if you stock, you're trying to match the demand versus the stock, the supply. If I supply 350, I'll only be able to serve what here? 0. If I supply, in this case here, 450, I'll be able to serve 19%. If I supply whatever, if I supply 950, then I shall be able to serve 100%. 100%. So we have our service level that has been defined there. But remember that this company does not want any of these service levels. This company wants a specific service level. The company wants a specific service level. And what is this specific service level? The targeted service level, they've told us there, required before the requirement, the company targets an 85% service level. You see, 85% is the same as 0.85. So 85% is the same as 0.85. So try to fix your desired service level here. Try to fix the desired service level here. The desired service level is in between 0.71 and 0.87. Because we are talking of 0.85. So this is what we call the desired service what here? Level. The desired service level. The desired service level. Desired service level. The desired service level. The desired service level. So ladies and gentlemen, having discovered that the desired service level is here, it means that we need to stock, we need to supply units that are in between 650 and 750. Because our 0.85 is in between. So I would want to make this very, very clear. I would want to make this very, very clear because we are saying that the company should stock. We are writing there that the company should stock or supply 650 units to 750 units to 750 what year units. Should stock 650 units to 750 units in between there. But you see, they want you to give them a precise figure. They want you to give them a precise figure. And this precise figure can only be obtained through interpolation. The precise figure can only be obtained through interpolation. So you want precision. So precisely, you can write there, precisely, we have 650 here, we have 750. And then we have our cumulative probability being 0.71 and a 0. What here? 87 like that. I've simply copied here to make things easier for us. To make things easy for us. So ladies and gentlemen, given these figures that we have, I want somebody in this case here to interpolate and they give me this X figure, which will correspond to 0.85, our desired service level. Could you kindly try that? And to see whether there is any student who can interpolate to give us the X quantity, which corresponds to 0.85. What do we have there, somebody? Just try. If you're not able to see whatever is being done, no problem. You simply type there 0. Or you say in German language, Akia Morgen. Akia Morgen means I know nothing. I know nothing. But of course, my students cannot really. Shindia is giving us what figure? 700. So what Shindia has done is to take this plus this divided by 2. 736. Pauline is getting a figure of 736. I'm waiting for the others to try. Fiona 778. Fiona is getting 7. They're almost there. Almost. I'm so sure the last person will comment will get this answer correct. Will get this answer correct. Will get this answer correctly. Will get this answer correctly. Will get the answer correctly. 738. Who gave us that answer of 738? Or even 736, Beatrice, eh? Very good. Now, ladies and gentlemen, for us to be able to interpolate here and get, in this case here, the optimal, we call it the optimal supply. What we will do is to come and start with the lower figure. So you start with the lower figure, which is 650, plus the difference between the two figures. The difference between the two figures, we have 750 minus 650, like that. And then now we interpolate these using these cumulative probabilities. How do we interpolate these? I'll come and multiply these with the upper arc. This is what we call the upper arc. The upper arc. So the upper arc difference will be 0.71 minus 0.85 all over what we call the base arc. The base arc has got the upper and the lower. Base is the total. That difference gives us 0.71 minus 0.87, like that, ladies and gentlemen. So then these, at the end of the day, will give us what here? We have 650 plus, this is 10, rather 100, 750 minus 650 is 100, times, pick up your calculator, give us the actual, or rather the upper arc difference. The upper arc difference, what do we have? We have 0.71 minus 0.85, which gives us negative 0.14. Negative 0.14 divided by 0.71 minus 0.87, giving us negative 0.16, like that. Of course, the negatives here will do what here? Will cancel out. And then what I need to do is to come and get the multiplication first. So 100 times 0.14 divided by 0.16 equals whatever I get here, we have here plus 600 what here? 50. Plus 650. 650. So, or they can't see the farthest corner. So which will end up giving us 700 what here? 737.5, which is 738. Allow me to repeat this again because most students cannot see. Cannot see up there. So in terms of interpolation, ladies and gentlemen, what do we have here? The lower, we start with the lower figure. So the lower figure is 650 plus, we have the supply difference here, which gives us 750 minus 650, like that. Times, we have what we call the upper arc. The upper arc is this one here, which will be 0.71 minus 0.85, all over the lower arc. The lower arc, ladies and gentlemen, is not lower, but total arc, the base arc, 0.71 minus 0.87, like that. Okay. If you remember IRR in finance, you also use the same approach. You also use the same approach. Lower rate plus difference between multiplied by the same. It's called interpolation. So then this will give us 650 plus, we have here 100 times, the upper arc there will be 0.71 minus 0.85, giving us minus 0.14 all over 0.71 minus 0.87, which will end up giving us negative 0.16. Of course, negatives here will cancel out. Negatives will cancel out. And then we'll talk of 0.14 divided by 0.16 times 100 equals plus 650, which gives us 737.5, which is basically 700 what here? 38. So if they want to be sure that they'll be serving 85% of their clients, they have to supply 738 units. They must supply 738 units. They must supply 738 units. Now, I would want to test you, great students of mine, in an easy way. If this is okay, please allow me to give you a small test. what if we have our midpoint here, 350, 400, 450, 500, 550, 600, 650, 650, 750, no, 350, 350, 450, yeah, sorry for that. Let me just rub everything I started. It's a difference of 100. So we have here 350. The next one is 450. We have 550. We have 650, 750. We have 850. And then lastly, we have 950. And then they have given us the cumulative probabilities very nicely, the first one being 0. Then we have here, the first one being 0. Then we have 0.19 cumulative, which already you guys have. We have 0.42, 0.42. We have 0.71, 0.71. We have 0.87, 0.87. We have 0.96, 0.96, and then we have 1. Now, what if our desired service level, what if our desired service level is 45%? Just somewhere there in your rough work. What if our desired service level is 45%? Then what will be the optimal supply? What will be the optimal supply? What will be the optimal supply? Let's see who will be the first one to get this. I'm just making use of the previous, or rather the question that you're doing, parameters. Parameters. I have my cumulative probabilities. And then now this time around, I've changed the desired service level, which is 45%. What do you think, ladies and gentlemen, will our optimal supply value be? I promised you a great class today, and indeed it's going to be my greatest AMA class. Same case for you, you'll be happy. Philip is getting what figure? So 561.5, that is 500 and what here? 62, 562. Any other person? Esau, 560 or 562? 560 exactly. Same with Mokami. Salome. Thank you very much. Now at 45%, where is 45%? It's in between here. So we have this being 0.45. 0.45. And if that is the case, ladies and gentlemen, remember the concept of the upper arc and the base arc, like that. So in that case here, then the optimal supply will be equal to the lower figure is 550 plus the difference between these two, which will be 650 minus 550 times our upper arc figure. Upper arc, you take this minus this. So that will give us what figure, somebody here? Upper arc figure will be 0.42 minus 0.45, which will end up giving us negative 0.03. Divide this by, we have this one here, 0.42 minus 0.71, which will end up giving us negative 0.29. Now from there, ladies and gentlemen, what do? We come and divide. So we have here 0.03 divided by 0.29 equals whatever I get times 100, because I know the difference here is 100, equals whatever I get plus 500 and what here? 50. So what figures do we have? We have 560.34, which is the same as what here, 560. 560. I hope now that is clear. Now, let's get back to our question. Our question, we have recommended to these people that they need to supply the optimal supply, is 700 what here? 38. The optimal supply is 738. But you see, we haven't yet answered the question. The question was about safety stock level, the excess quantity which you are stocking, the excess quantity which you are stocking, which is not supposed to be used under normal situations. So out of this figure, who can give me the parameter of safety stock? Could you kindly give me safety stock out of this? Safety stock. Or is it the whole of these 738 units here which are going to our buffer? No, no, it can't be. It cannot be. It cannot be. Pauline says 88 units, yes. The same. So what these students have been able to know is that for them to get the safety stock, they need to come under less. They need to come here under less the consumption during lead time. Less the consumption during lead time. During lead time, which we are done in part A, which was 650. Remember, part A, we said that our current drop was 650. So anything over and above this 650 becomes what here? Becomes safety stock. Therefore, the safety stock will be equal to 738 minus 650, which gives us what figure, somebody here? Which gives us 88 like that. 88. So please, I would beg you allow me to go to the second question, which is May 2016, question number 3, boy. May 2016, question number 3, boy. May 2016, question number 3, boy. So May 2016, question number 3, boy, is a very interesting question. You have to give it a title, May 2016, question number 3, boy. We have to give it a title, perishable. Perishable. Perishable goods. Goods that perish with time. With time. Perishable goods. Goods whose value reduce as time passes by. This could be like fruits, vegetables, anniversary cards, anything that is time bound, like newspapers. Once in this case here, you don't sell your newspaper, for example, by the end of today, if you have to dispose it say tomorrow, the price will go down, bait and the chimney. So let us try to understand this question very well. We are told here, Jamie Makali prides himself as the largest sausage supplier in the city. Small, freshly baked sausages are the specialty of his shop. So sausages, specialty of his shop. He has sought help in determining the number of sausages he should make each day so as to maximize his long-run profitability. From analysis of past demand, he estimates the demand for sausages as follows. So could you kindly copy that question down, that table down? So we have the demand. We have the demand. So demand, ladies and gentlemen, demand. What do we have here for demand? So demand, we have 1800. We have 2000. We have 2200. We have 2400. We have 2600. From there we have 2800. And then we have 3000. That is supposed to be a column of probability There's a small error there. That cannot be profitability. That's supposed to be probability. Probability, not profitability of demand. It's probability. So probability, we have 0.05. We have 0.1. Next year, we have 0.2. After 0.2, ladies and gentlemen, we have 0.3. 0.3. From there, we have 0.2. 0.2. From there, we have 0.1. And then we have 0.05. If I'm the one doing this, I'll have to test and see whether my probabilities are adding up to 1. That is a very important test. Very important test. So we have 0.05 plus, 0.1 plus, 0.2 plus, 0.3 plus, 0.2 plus, 0.1 plus, 0.05 equals. So I'm getting exactly 1. I am safe. If, for example, I got a different figure, then I should have made some adjustment somewhere. Although, for a question given by the examiner, you'll not really be required to do any adjustment. Normally, any question given by the examiner will have to agree. Okay, sorry for that. You'll bear with me. This battery has been on. This camera has been on for so long. You'll bear with me. We will just continue changing it like that. But at the end of the day, I told you you'll enjoy the class. So we are told here additional information. The selling price per packet amounts to 90. That's not number 1. Not number 2. The cost per packet, which includes handling and transportation, amounts to 65. So the cost is how much? 65. Sausages that are not sold at the end of the day are sold as day-old merchandise the following day when they have perished. At what cost here? 30 per packet. Required, using continuous analysis of probability distribution of demand, advise on the optional production quantity in packets for the sausages. So as a good student of management accounting, I'm able to understand that here I'm dealing with a product that is perishable. And that is why they have given us 2 selling prices. And because it is a perishable item, ladies and gentlemen, the first thing that I will do is to assume that I will be able to sell my sausages normally. So if I'm able to sell this sausage normally before perishing, what will be my marginal profit? So calculate for us, first of all here, the marginal profit. So give us what we call the marginal profit. So marginal profit, of course, you can only earn a profit if you are able to sell this sausage within the day. And if we sell it within today, you can see the selling price in note number 1. The selling price per packet amounts to what here? 90. Minus what this thing cost us. This thing, ladies and gentlemen, had cost us what here? 65. This thing had cost us 65. It had cost us 65. So if it's a question of a perishable item, never forget this marginal analysis. And how will I be able to know that the question is a question of perishable item? When you are told that the price of this commodity is, for example, reducing as time passes by. If you don't sell it today, you will sell it tomorrow, but at a lower price. Then that is an item that is perishing. An item which is perishing, we normally use marginal analysis. The first thing you do is to give us marginal profit, and then come and give us what we call the marginal loss. Marginal loss is applicable if the product perishes. If we sell it tomorrow. If it perishes, what price are we going to fetch from note number 3? Sausages that are not sold at the end of the day are sold as day-old merchandise the following day at a nominal price, a price of 30, minus, of course, the cost. The cost doesn't keep on fluctuating. The person who is selling to you these sausages does not care whether you're going to perish with them or not. So 30 minus 65, that gives us what here? Somebody 35. Of course, we can't put a negative there because you have made use of the word loss. You can't say that Kenya Airways has made a loss of negative 10 billion. It has made a loss of negative. That one, people will wonder who really was your teacher when you were doing accounting. The moment you make use of the word loss, omit the negative like that. So for marginal loss, leave it the way it is, without, in this case here, without, ladies and gentlemen, without the negative. Now, if it's marginal analysis, I know after I've gotten the marginal profit, I've gotten the marginal loss, the next thing will be for us to define probability of success. The third step, you define probability of success. So come and give us here 90 minus 65. By the way, you need to have given me this figure. 90 minus 65. You need to have given me this figure. 90 minus 65 gives us 20 what here? 25. This gives us 25. So I'm saying that the next step will be for you to give us what we call the probability of succeeding. The probability of success, which is normally abbreviated by P. Probability of success, which is normally abbreviated by P. Probability of succeeding. Remember, for us, success is the ability of selling everything. Selling everything. If, for example, I'm a fishmonger, I'm selling fish, I would rather people coming asking for fish, I tell them that, no, I have depleted my stock, than them coming, they get me a lot of fish today, and then I perish with them. I don't sell them within the same day. That will be unfortunate because I'll have lost value coming the other day, coming the next day. So how do we get this probability of success? To get probability of success, ladies and gentlemen, we normally use this formula. You take the marginal loss all over the marginal loss plus marginal profit. Please write that in full. To get probability of success here is a formula, very important formula, which is marginal loss all over marginal loss plus marginal what here? Profit. Plus marginal profit. So remember, in these workings of ours that we have already deleted, we had gotten the marginal loss. Marginal loss was 35. All over marginal loss again, which is 35 plus marginal profit that we got there, which is 25. So could you kindly give me this answer in terms of 2 decimal places? In terms of 2 decimal places. In terms of 2 decimal places. In terms of 2 decimal places, what do we have? Kennedy is getting 0.58. Clement the same. Clement the same. Where is the girl child? I am told the third one is the sow. The girl child. Pauline, 0.58. Yes. Thank you very much. Thank you very much. Now, ladies and gentlemen, from there, I will come very fast and do what we call cumulative probabilities. Come and do cumulative probabilities, something that I would want to give you 1 minute. You accumulate these things downwards for me very fast, or rather accumulate them for me. Accumulate them for me. Just try your best to accumulate them for us. Accumulate them for us. Accumulate them for us very fast until you get one somewhere there. Until you get one somewhere there. Accumulate them for us. So you accumulate them for us, ladies and gentlemen. At the end of the day, what are we going to get? What is our very first cumulative probability here? Somebody in the comment section. What is our very first cumulative probability in our 0 point? a lie. How many of them are saying 0.05? Several. A lie. A lie. Ladies and gentlemen, remember that this is a perishable item. This is a perishable item, meaning that we cannot treat these cumulative probabilities normally, not unless you want to get a wrong. For perishable items, remember what your teachers told you in classes. For perishable items, ladies and gentlemen, we normally start accumulating from down and then we move up. So here, the cumulative probabilities will be done in an orthodox way. We normally do it upwards. Upwards. So upwards, what do we have? So you can grab your column very fast. We start getting them afresh. So we have 0.05 upwards, 0.15 upwards. So here, because it's a perishable item, we are getting our cumulative probabilities upwards. So we have here 0.15 plus 0.2, giving us 0.35 plus 0.3, giving us 0.65 plus 0.2, giving us 0.85 plus 0.1, giving us 0.95 plus 0.05, giving us 1 exactly. So before I explain why, I would want you to understand, if a product happens to be having two prices which are reducing for that matter, two selling prices which are reducing for that matter, where we have perishability being exhibited, whenever it comes to cumulative probabilities, we normally get them how? Upwards. Upwards. Ladies and gentlemen, remember, for us, in terms of a perishable item, if we decide to stock 3,000, we only have this particular chance, 0.05, of being able to sell everything. We only have one chance when demand will be 3,000. If I decide to stock, if my supply is 2,800, then there are two possibilities of being able to sell everything. In this case here, being able to sell everything, not perishing with anything. If I stock 2,800, there is a possibility that the demand will be this with this probability, or it will be this with that probability. We don't want to go to much explanations. What you're supposed to know, whenever you hear that a product, ladies and gentlemen, is a perishable item, I'll be able to take you to various questions in your past papers where they are talking of these perishable items later. If it's a perishable item, ladies and gentlemen, always remember the reverse gear of getting cumulative probabilities. It is after you have done that, remember this is known as the success levels. Success levels. That if you want to succeed 100%, stock very few items. If you stock very few items, if your success is being measured in terms of the ability to sell everything, then you'll be guaranteed of selling everything. But remember, they don't want these success levels. There is a desired success level. The desired success level, the desired success level, the desired success level, the desired success level is 0.85, 0.58, I mean. So ladies and gentlemen, with this desired success level, I would want somebody to do some abracadabra and interpolate for us. Give us the exact number of units that we need to stock. Give us the exact number of units that we need to stock. Because here there is some interpolation. There's some interpolation. Take like a minute and give me the exact quantity that we need to stock. Take some 5 minutes. Give me the exact quantity that we need to stock. Where 0.58 is coming from. Do you remember we used some formula? Probability equals ML over ML plus MP. Right? Right? So ML, if you can recall, marginal loss was 35, all over 35, plus MP, which is what here, 25. Beatrice has been with us throughout, isn't it? Thank you very much. Thank you very much. So now using interpolation, please give me an answer. Is there somebody who was there? Not yet, okay. Great. So the thing that I would want you to take home today, whenever you see a perishable item, always remember reverse gear. The down, up, accumulation of probabilities from down, up. Anyone who has an answer? Not yet. So allow me to do it then. This one, okay. What figure is he getting? 23, 53, 23, 53. Clement, 23, 42, 27, 53. Thank you very much for trying. So remember, where is our 0.58? Of course, it's not in between here. Our 0.58 will be found here. This 0.58. Meaning that in terms of precision, to be very precise, what will I talk about to be very precise? So to be very precise, ladies and gentlemen, our optimal supply, our optimal supply, ladies and gentlemen, will be equal to what here? Our optimal supply, it's falling here. You start with the lower, plus the difference between these two, 2600 minus 2400. Multiply this by the upper arc. Where is the upper arc? It is here. It is 0.65 minus 0.58 divided by the base arc. So the base arc we have here 0.65 minus 0.35, like that. So ladies and gentlemen, the moment I hit there, then I should be able to get this answer very easily. I should be able to get this answer very, very easily. So what do we have here? We have 2400 plus into brackets 2600 minus 2400 close times open brackets if I wish 0.65 minus 0.58 close, divide this by open brackets again 0.65 minus 0.35 close, which gives us 2446. So 2447. Is there somebody who got that kind of an answer? Salome. Those two. Mary and Salome got it. I hope the other students have been able to see where they went wrong. Okay. So if you allow me, remember in terms of perishable items, there are two ways of tackling a perishable item. There are two ways of tackling. Sorry for that. So we come back here. So there are two ways of tackling a question of perishability. The first way is the one that I've shown you, interpolation. The second way, nile ambayo tunatumia kala kaugali kamluya. And the examiner will always be specific. He'll tell you whether to use the interpolation method. What we have done here is interpolation, or he'll tell you to use normal probability distribution. So mention there normal probability distribution. So mention there normal probability distribution. Don't forget that this normal probability distribution is the one that is normally called the continuous probability distribution. The continuous probability distribution. If you look at this question, the requirement part, please go to the requirement of this question. So many students did this question using the interpolation method, and anytime you could see any student doing it using interpolation method, we were giving very few marks. Why? Because the examiner here required, look at the required, using continuous analysis of probability distribution of what? Demand. Using basically the continuous what here? Distribution. The continuous probability distribution, they want us to advise on the optimal, that's supposed to be optimal, to advise on the optimal production quantity. Optimal production quantity. So continuous means what, ladies and gentlemen? Continuous means that we are using our normal curve. And if it is our normal curve, the first thing that we need to do is to come, ladies and gentlemen, and draw our ugali like that. Remember that our ugali is defined using U and the standard deviation. This one is normally ascertained using, or rather defined using the mean. Remember, U is the mean. The mean. It's also known as X bar. Or rather, and the standard deviation. This is standard deviation like that. So what good students did in this sitting, they were able to calculate the mean from the probability distribution given. They calculated the mean very fast. So please come and give us the mean. Give us the mean. Give us the mean. Give us the mean. Mean and standard deviation. Mean and standard deviation. So remember, we have our demand, which is the same as our X. So the demand, what do we have there? We have 1800. Then we have 2000. 2200. 2200. Then we have 2400. Then we have 2600. 2600. Then we have 2800. 2800. And then lastly 3000. And then what we have here, ladies and gentlemen, are probabilities. The probabilities that we have been given, the first one is 0.05, 0.05, then we have 0.1, then we have 0.2, then we have 0.3, 0.3, 0.2, 0.1, and then 0.05. For purposes of getting our mean, what we need to do is you multiply the two columns. So come and create a column here of XP. For us to be able to get the mean, create a column of XP. So you take this by the probabilities, and then you give us answers very first. So the first one will be 1800 times 0.05, which gives us what figure, somebody here? 90. The first one is 90. The second one is 2000 times 0.1, which gives us 200. 200. From there we have 2200. 2200 times 0.2, giving us 440. From there we have 2400 times 0.3, giving us 720. From there we have 2600 times 0.2, giving us 520. From there we have 280. And lastly we have 3000 times 0.05, giving us 150. So from there, come and give us the mean. The mean is summation of all X values here times their probabilities. So you sum them up. Sum them for us. So what do we have here, somebody? What we have here will be 90 plus 200 plus 440 plus 720 plus 520 plus 280 plus 150 equals, I'm getting 2,400. Is there someone else who is able to get this figure? Clement has gotten this. So in my normal probability distribution, I've been able to get X bar or U as 2,400. I've been able to get one parameter. But now I'm also in need of what here? Standard deviation. I am in need of standard deviation. So how do I get standard deviation? I would want to see standard deviation. Remember, you write as 0 and then you pull a tail. It's as easy as that. This is a professional way of writing the standard deviation. I've always gotten students who try to write it, but they write it in a bad way. They write it as if it's a mitochondrion they're drawing. This is not professional. This is unprofessional. Very unprofessional. Standard deviation is like that. So then who is able to remember the formula of standard deviation? Let's see. Standard deviation. Is there somebody who has been able to define there for us the formula of standard deviation? Not yet. Just try. I know it's quite hard even to get the square root, but just try to even write the word square root into. I'm so sure you'll be able to give us this very well. Is there somebody who has been able to write the formula? Not yet. I'm waiting. I'm patient. Yes, squared up there. Yes. Clement is doing very well. What Clement has been able to remember is that, ladies and gentlemen, when it comes to the standard deviation, we are looking at the difference between our actual values, which is x, from the mean. So x minus what here? X bar. X minus x bar. But now remember that this standard deviation is a special thing. It's not just your normal deviation. So the deviations here must always be squared and multiplied with what here? Probability. And then remember now these deviations are many, you must come and sum them up. And then of course it can't be really standard deviation if it doesn't have what here? A square root. If it doesn't have a square root. So please first of all write that. If it doesn't have a square root. So come and create a column here very fast where you talk of x minus x bar squared times probability. So the first one here, x is this 1800 minus x bar, which we got here as 2400. Whatever we get, we do whatever we square times the probability. Whatever we get, we square times this probability, which is 0.05. So please give us an answer. So first of all, I'm getting what is under the square root. Someone is giving me a figure of 18,000. How many were able to get 18,000? There is only one student. Clement, thank you very much. Go to the second one and give me the second figure. Please give me the second figure, the third figure, etc, etc. Second figure. What do? It's x minus x bar. X bar is known in advance. And remember, x bar doesn't keep on fluctuating. X bar remains the same. So like now here, we have 2,000 minus 2,400 x bar. 2,400. Whatever I get, I square times the probability of this, which is 0.1. Then I continue like that. What is the second figure supposed to be? 16,000. 16,000. Thank you very much. Go to the third figure. Go to the third figure. Go to the third figure. So the third figure, what do we have there? Changamuka kabisa, changamuka. Hii kitu so long as unaongea taka unaongea kwa kutype tu, utapita mtihani yako. So I'm being told it's 8,000. Please continue like that. Finish the entire thing. Finish the entire thing. Finish the entire thing. What now I'm interested in is the summation. I'm interested in the summation of those things here. I want the summation of those things. I want the summation of those parameters. The total answer is supposed to be 84,000. Is there anybody who is able to confirm that 84,000? Anyone else who is able to second Clement? Okiri Frederick. All of us, are we able to get this 84,000? Yes or no? Are we able to get this 84,000? All of us? Yes, Lou says yes. Thank you very much. So having gotten this 84,000, then this is not your standard deviation. This is what we call variance. We are in need of the standard deviation, so I need to come and take the square root of that. So you can label there this figure we have gotten there to demonstrate broad and deep understanding of the subject. The figure we have gotten here is called variance. And ladies and gentlemen, variance, to change it to standard deviation as per the formula, as per our formula, our standard deviation will be equal to the square root of the variance, which will be equal to the square root of 84,000. So then at the end of the day, we'll end up getting what parameter? So square root of 84,000 will end up giving us what figure? I'm waiting for the answer. 289.8, yes. 289.8. Thank you very much. Thank you very much. So I'll come and put this figure in my ugali. Continuous probability distribution. Hiyo ni ugali. Ugali kama saizi ukipata ugali ya Mluya lunch time nzuri namna hii. Oye, what do we have? So we have like that. We have this. So we have our U, we have our standard deviation. Our U, if I'm not wrong, was 2,400. And then, ladies and gentlemen, we have our standard deviation that we have just gotten here of 289 point what here? 8. And then now they want us to advise them in terms of the optimal level. So the optimal level, I need the probability of success. So probability of success, if you can remember this bit trace, we got it. It is supposed to be 0.58. Probability of success is supposed to be 0.58. 0.58. Probability of success is supposed to be 0.58. So remember, half of this is 0.5. And then I want to build it up to 0.58, meaning that there is a small section here which will take care of 0.08 for us to get the total being 0.5 what here? 0.58. For us to get the total being 0.58. Now kama ni hesabu ya Mluya, lazima ukuje ustandardize, upate the Z score. Who remembers the formula of z-score? Somebody, could you kindly write for us the z-score formula? The z-score formula. Z-score formula. What do we have there, somebody? Z-score, Z-score, Z-score for normal probability distribution. What do we have there? Z-score. So Z equals X minus mu, isn't it? Divided by what your standard? It's a formula. If I'm doing AFM, if I'm doing AMA, it's a formula that's got to be at the back of my mind always. The one of standardization. So come and continue with this. So you're saying that our Z will be equal to, we don't know what this X figure is. X figure, we don't know it. So it is X minus U. U is this, the mean. So minus 2400 divided by the standard deviation. Standard deviation, which is 289. It was 289 point what? I've forgotten my figure. 289.8. Thank you very much. Now, of course, if the examiner doesn't give you X, when he wants you to calculate X, then he'll have to give you information that will help you to get Z. So I want to see whether I've got very good students who will be able to give me the value of Z using these probabilities that we have here. So please get out your normal table and give us the Z value there. Give us the Z value there. I'll give you a break of 3 minutes. A break of 3 minutes. You give us the Z value. Is there somebody who has been able to give us that Z score? 0.1? 0.2. I like that. That is okay. Negative 0.2. It can't be negative. It can't be negative because of what here? Because of you know, it's a figure which is on the right hand side. It's on the right hand. So if it's on the right hand side of the mean, it has to be positive. It has to be positive. It has to be positive. So it is what is being asked in the question. Are we still working on Z score? No. You see, we want to get Z score, which now will help us to get the value of what here? Value of X. We want to get Z score, which will help us to get the value of X. So how do we do it? Fortunately, they have given us probabilities. And the probability that I have interest in is the probability between these two values that I've subtracted. The probability between the two values. So the probability which I'm looking at, the probability which I'm looking at is 0.08. So go inside your normal tables, and look for 0.08. Inside your normal tables. Go inside. So we have here Z score. So please look for 0.08 somewhere there. I don't know whether you have something you can project to them. 0.08, somewhere here. Okay. So 0.08. So if you're keen, the moment you see something that is quite close to this, what you need to do is to come and read the Z which is here. I can see some students are saying it is 0.2. And then of course 0.2. So I have on the header here, it's like most of them are able to see 0 there. And that is why most of them are saying that the corresponding Z is 0.20. The corresponding Z is 0.20 or 0.21. Nobody will be able to penalize you if you have 0.21. We want to take your time to understand this very well, that they want us to give them the value of X. And that is why they're giving us what here, somebody? Z. That's why they're giving us Z. Yeah, my brother is trying to get that table to project for you. Let's go to the second page. Take time. Next page. Okay, ladies and gentlemen, I think, okay, great. Yeah, you can see that normal table now. Are you able to project it to them? Yes, so you can see this T table. Look for normal table. Go again. This is a normal table. Area between 0 and Z. So area between 0 and Z, I'm looking for 0.08. So if you look for 0.08, if you can just point to them here, you'll see 0.0793. You're able to see 0.0. So we have here Z, then we have here 0.2, and then I'll be able to see 0.07, 0.0793. And then, of course, on top of this, I can see a 0 there. And then, ladies and gentlemen, the other one is 0.0832. So we have here 0.0832. Then we have got what here? 1 on top there. We've got 1 on top there. So ladies and gentlemen, what I want to do is to get the one that is quite close. So the one that is quite close, in my mother tongue, I'll say this is just 7 units away in mother tongue. 7 units away. But if you look at this was exceeded by a whole 32. A whole 32. So what you want, ladies and gentlemen, is the one that is close. So the one that is close, if I'm able to see, it is this one. And its corresponding Z will be 0.20 like that. So the corresponding Z there is 0.20. So you say equals 0.20, and then you make X the subject of the formula. You make X the subject of the formula. Make X the subject of the formula, and then you give me the answer there. Make X the subject of the formula. Make X the subject of the formula. If you're to make X the subject of the formula, this is how it shall look like. We have X minus 2400 equals 0.2 times 289.8. So then this will be X minus, these are sad, very many interruptions. Okay, so we have here X minus 2400, X, or rather X equals 0.2 times 289.8 plus 2400, plus, because this has to cross over. When it crosses over, it becomes positive. So then at the end of the day, we'll have here 0.2 times 289.8 plus 2400, which will end up giving us, ladies and gentlemen, 2458. And therefore, the optimal supply is 24 what here? 58 units, using this formula called continuous normal probability distribution. Of course, the answers may not be exactly the same. That's why we have to be cognizant of the formula which the examiner wants us to use. Any question? Any question? So, ladies and gentlemen, I would want us to go to the last area of this, which is called simulation. Simulation of inventory problems. We are looking at stochastic models. So mention their simulation. Mention their simulation of inventory problems. Simulation of inventory problems. Simulation of inventory problems. Now, the key thing that you're supposed to know under simulation, ladies and gentlemen, is what we call the random number ranges. In section 5, there is nobody who even ask you to define what simulation is. Just know how to get random number ranges. So if you're given here, for example, X, and then they have given us probabilities. So we have here 10, 20, here we have 0.2, here we have 0.8. In terms of random number ranges, who can give us the basic steps? How do we get random number ranges, which are the key parameters of simulation analysis? The first thing that we need to do is to come and provide what we call cumulative probabilities. We provide the cumulative probabilities. So step number 1, cumulative probabilities, the normal one. These are the perishable item, the normal one. So we have here 0.2, and then we have 1.0. Out of these cumulative probabilities, I should be able to get random number ranges. I should be able to get random number ranges. I should be able to get random number ranges. Remember, my random numbers normally depend on the decimal places. So if you have got one decimal place, you are going to have one digit. You're going to have one digit. One digit running from one digit, which will run from 0 to 9. So single digits. If you have got two decimal places, you shall be having two digits. So these two digits, how do they look like? We have 00 to 99. Two decimal places, we shall be making use of two digits. The two digits are here, 00 to 19 to 99. 00 to 99. Now, ladies and gentlemen, if you look at the question that we have here, we have a single decimal place, one decimal place. And if it's one decimal place, then we shall do it this way. We'll take 0 all the way to the upper limit for this. So it will be one digit. We take 0 here, all the way to the upper limit. How do we get the upper limit here? Normally, to get the upper limit, we take the figure that is here minus what? Minus 1. So 2 minus 1. Always you take the figure that is here as if it's a whole number minus 1. So 2 minus 1 gives us what figure? Somebody, it gives us 1. From there, we go to the second class. The second class, we begin from the next number after 1, which is 2. All the way, ladies and gentlemen, to the upper limit. How do we get the upper limit? We take the number that is here as if it's a whole number, which is 10 minus m1. So 10 minus 1 gives us what figure? Somebody here, it gives us 9. It gives us 9. It gives us 9. So, ladies and gentlemen, I would want us to try another one. What if you are given this kind of a question? We have 10, 20, and then they have given us probabilities. We have perhaps here 0.20, 0.30, and then we have 30 here with 0.50. How will we be able to get random number ranges for these? To get random number ranges for these, the first thing that we shall do is to accumulate probabilities. So accumulate probabilities downwards. So we have here 0.20 plus 0.3, that gives us 0.50. Plus 0.5, that gives us 1.00. 1.00. After this, now we should be able to pull the random number ranges out of them. So remember now, these are how many decimal places? 2 decimal places. You can't say that we ignore the 0 here. No. For simulation, this 0 is very significant. So now we are talking of 2 decimal places. So please try to give me those random number ranges. Sorry, today we underestimated the number of classes. So we are in short batteries. But we shall overcome. So random number ranges, these are two decimal places. So we are talking of 2 digits, which will be 00 to 20 minus what here? 1. 20 minus 1 gives us what here? Somebody? 19. From there, we start working on the second class. Second class will be 20. 20 all the way to 50 minus 1. 50 minus 1 gives us 40 what here? 49. After 49, the next number is 50. So 50 all the way to 100 minus 1. 100 minus 1 gives us what here, somebody? 99. So for us to understand, there is a question there which Kasneb gave my students. You'll be able to see it there. It's November 2011, question number 4. November 2011, question number 4. November 2011, question number 4. It is on the screen there. November 2011, question number 4. So what I want us to do, because it's a simulation question, I want us to copy the probabilistic variables first. We copy the probabilistic variables. Copy the probabilistic variables. So copy those variables with the probabilities. We have two of them. We have demand and the lead time. So we have demand. What do we have there as demand? I can see demand in terms of units. We have 0, 1, 2, 3, 4, 5, and then 6. So this demand, they have given us probabilities. So what do we have here for probabilities? We have 0.02, we have 0.08, we have 0.22, we have 0.34, we have 0.18, we have 0.09, we have 0.07. So with this, what we need to do, come and give us cumulative what? Probabilities. Give us cumulative probabilities, and then you give us random number ranges, and then lastly we have the lead time. The lead time, you also need to straight away get the cumulative probabilities and random number ranges. And then if you don't mind, unfortunately, because of this problem of batteries, we have to bring this thing to a close, to an end, but I'll know how to make up for all the lost time. I'm so sorry for that. But I want to believe that you have picked something, however small. I was so ready to give you so much, but unfortunately, our technology has let us down as I have a device there on WhatsApp, so I'll be able to know what to do. Otherwise, bye-bye. I'm so sorry.